Okay, let's get ready for notes number 21. And this is a big day because today we get to talk about the quadratic formula. And there's a pretty good chance that you have learned to use the quadratic formula in the past, but today I'm hoping that you see how it connects to the other things that we're doing. We're also going to throw in a little extra today, graphing quadratic inequalities. Now, for the beginning of the lesson, you don't have to watch this part that you don't have to watch. You don't have to write this part that I am about to show you. Just watch. Please do watch. So, what I'm going to do is take this problem and I'm going to complete the square. That's from our lesson from yesterday. So because we have a leading coefficient of 3, I'm going to divide the whole equation by 3. So that would be x squared minus 4/3 x plus 7/3 equals 2/3. Okay, now I need to make a perfect trinomial square. So I'm going to subtract 7/3 from both sides just to kind of get it out of my way. That's going to give me negative 5/3, and then whatever number I add to the left, I need to add to the right. So to find the number that goes in the box, we take half of this number, which would be negative 2/3, and square it, and that's going to give us 4/9. So we add 4/9 to both sides. Okay, so now we have a perfect trinomial square, and it factors into x minus 2/3 quantity squared. And then on the other side, we can add these two fractions together. So to get a common denominator, I'm going to multiply by 3/3 on my first fraction. So now that's going to be negative 15/9 plus 4/9. We have negative 11/9. And now we're ready to square root both sides. So that's going to leave us with x minus 2/3 equals plus or minus the square root of negative 11 over the square root of 9. And then we add 2/3 to both sides, and then we simplify the radicals. So we have 2/3 plus or minus I square root 11 over 3. Okay, so that's just an example of completing the square. Now what you're going to see is I'm going to go through that entire process on this equation, ax squared plus bx plus c. So whatever I did with the first equation, I'm going to do with this one. So in the first one, I divided both sides by 3. So here I'm going to divide both sides by a. And we have x squared plus b over a times x plus c over a equals 0. In the other one, the next thing I did was subtracted my constant to get it over to the other side. So x squared plus b over ax, and then leaving the space for completing the square. So I'm going to subtract c over a. And now we find the number that completes the square. So we take half of this number, and that would be b over 2a. And then we square it, and we get b squared over 4a squared. And that's what we add to the other side as well. Oops. Okay. And then what I did here was get a common denominator so that I could add those fractions together. And so my common denominator needs to be 4a squared, so I'm going to multiply the top and the bottom by 4a of the first fraction. And then we can write this part in its factored form. So that's going to be x plus b over 2a, quantity squared, equals, and then for adding these fractions together, they have a common denominator of 4a squared, and it's going to be negative 4ac plus b squared, and I'll write that as b squared minus 4ac. Now, you might be starting to think this looks familiar if you remember the quadratic formula from your past. So now we're ready to square root both sides. So that's going to leave us with x plus b over 2a equals plus or minus the square root of the top over the square root of the bottom. And then to get x by itself, we're going to subtract b over 2a from both sides. So we have the opposite of b over 2a, plus or minus, and then to simplify the radicals, well, we need to leave the square root of b squared minus 4ac. But on the bottom, we have the square root of a perfect square, so that would just be 2a. Okay, so this is our quadratic formula, and it is the solution, or the set of solutions, to the equation ax squared plus bx plus c equals 0 that was derived by completing the square. So the quadratic formula is nothing but completing the square. So here's how I want to write it. It's a theorem, basically, and you know from your geometry experience that theorems have a condition and a conclusion. If, then. So if ax squared plus bx plus c equals 0, then x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now, I know that most of you have seen this before as a single fraction like this. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Yes, that's equivalent. There's nothing wrong with it, but I have my reasons for liking it this way better. There are two main reasons. One is that a lot of students make mistakes when they're trying to simplify their fractions if it's all together. They'll simplify part of it and forget to simplify the other part. And the other reason is because we're going to see as we go back to looking at the graphs of quadratic functions that this has meaning. X equals opposite of b over 2a has meaning. In fact, we already know. Well, nope, I think I'm putting the cart before the horse. I'll just leave it at that. That has graphical meaning, and that has graphical meaning as well. Okay, now part of the quadratic formula is known as the discriminant. The part that is inside the radical, so b squared minus 4ac is known as the discriminant, not including the radical sign, just the part inside. And it's called the discriminant because its value helps you discriminate, and I mean that in a good way, not a bad way. Discriminate meaning figure out which case is what. So if b squared minus 4ac is positive, that means something. If it's 0, that means something. If it's negative, that means something. And we're going to explore that as we do our examples today. Okay, this first example is just to use the quadratic formula to solve for x. And remember that in order to use the quadratic formula, you need your equation to be of the form ax squared plus bx plus c equals 0. So let's subtract 2 from both sides of this equation. And then we can go ahead and use the quadratic formula. Now, in this case, a is 3, b is negative 4, and c is 5. So we have x equals the opposite of b, 4, over 2a, 6, plus or minus the square root of b squared, 16, minus 4ac, so minus 4 times 3 times 5, all over 2a, so over 6. Now let's reduce the 4/6, and that's 2/3. Let's simplify the discriminant. So that would be 16 minus 60, I think so. And 16 minus 60 is negative 44. And that's over 6. So now we simplify the radical. So because there's a negative there, we can write I, square root 44, and because 44 is divisible by 4, we can pull out the square root of 4 and we have 2. So 2i square root 11 over 6, and let's reduce the 2 over 6. So we have 2/3 plus or minus I square root 11 over 3. Those are the values of x. And chances are, if you look up your answer in the back of the book, it'll say 2 plus or minus I square root 11 over 3 all together. So writing your answer either way is fine. Okay, we're going to throw a bunch of ideas together and kind of bring this chapter all together from the beginning. So I'm giving you 3 problems to work on, and in each one, I want you to find the y-intercept. So remember, that's where x equals 0. Find the x-intercepts. That's where y equals 0, so use the quadratic formula for that part. Find the vertex, and graph the function. And then we'll discuss what the discriminant is doing and how that impacts how the graph looks. So I would recommend that you pause and give all of these a try. Okay, so I'm going to work through number 2, and if you haven't already discovered, you can watch the video at double time, which is kind of fun because it makes my voice sound funny, but also it'll get you through it faster. Or if you don't need to see any of the work worked out, you can fast forward. So I'm just going to talk through what I do. So the y-intercept has an x-coordinate of 0, so that's going to be 0, 13. To find the x-intercepts, I'm going to set the y value equal to 0. So that gives me x squared minus 8x plus 13 equals 0. And I'm going to use the quadratic formula to solve that equation. So x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. And that's going to simplify to be 4 plus or minus the square root of 12 over 2. And the square root of 12 simplifies to be 2 square root 3. And then we can reduce. So we have 4 plus or minus square root 3. So for the x-intercepts, let's give those as exact points, not approximate. So we have 4 plus square root 3 comma 0 and 4 minus square root 3 comma 0. And once we get to the point of graphing, we can approximate those. Now find the vertex. Okay, I forgot when I was talking earlier and I said I was putting the cart before the horse. I forgot that we actually already figured out in a previous lesson that to get the vertex, you need the opposite of b over 2a as your x-coordinate. And do you realize that in the quadratic formula, we already have the opposite of b over 2a? That was that graphical meaning that I was alluding to earlier. So we already know that the x-coordinate of the vertex is 4. So then to get the y-coordinate, we need to put 4 into the function. So what's f of 4? 4 squared minus 8 times 4 plus 13. And that's negative 3. So the vertex is 4, negative 3. Okay, by the way, the discriminant is what I'm looking for to go in that blank. Remember, the discriminant was the number inside the radical in the quadratic formula. So in this case, the discriminant is positive. The roots, those are the numbers we get when we set the function equal to 0. We got 4 plus or minus square root 3. Those are real. And so because we got real roots, we have 2 x-intercepts. Any real root is an x-intercept. Any non-real root is not an x-intercept. Okay, so now I'm going to work on my graph. So the first thing you do is you just look at your points and you stop and think about what would be logical for a scale and where your graph's going to end up. And then we can plot the y-intercept at 0, 13. We can plot the vertex at 4, negative 3. If you're using graph paper, it's probably even better. And then the approximate values of 4 plus square root 3 and 4 minus square root 3 are 5.7 and 2.3. So x-intercepts. And don't forget, we also know about the axis of symmetry, which goes through the vertex. Oops, there we go. And so we could use that to reflect the point that was on the y-axis across. And here we have 5 points. I think everything that was listed has been graphed, so let's just go ahead and draw the parabola. Okay, there's number 2. Number 3. Oh, by the way, we can also think about whether it's going to open up or down. So like on number 2, we knew it was going to open up because it had a positive leading coefficient. This one has a negative leading coefficient, so it's going to open down. The y-intercept is going to be 0, negative 2. Let's find the x-intercepts by taking the equation, setting it equal to 0 because we're putting 0 in for the y value. I'm going to divide the entire equation by negative 2. So x squared minus 2x plus 1 equals 0. And then let's use the quadratic formula. So we have opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. So that gives us 1 plus or minus the square root of 0 over 2. And that's 1 plus or minus 0, and that's just 1. So there's only one x-intercept, it's the point 1, 0. And let's stop and talk about the discriminant. The number inside the radical was 0. Okay, and the root is real. There's just one, but it's real. 1 is a real number, and it has one x-intercept, just that same number twice. Okay, for the vertex, again, we're going to use opposite of b over 2a, and we already know that opposite of b over 2a, the first part of our quadratic formula, is 1, and we already know that when x equals 1, the y-coordinate is 0. So the vertex is the same as the x-intercept. So let's put all that together and draw our graph. It's opening down, and the numbers we came up with here are pretty small numbers. So just going by ones, you'll probably be fine. We have 0, -2. We have 1, 0. We have our axis of symmetry. And then let's reflect that 1, 0 across. And remember that pattern I taught you in the beginning of the chapter where if you have a vertical stretch of 2, from the vertex, over 1 down 2 instead of over 1 down 1. And instead of over 2 down 4, it would be over 2 down 8. So if I'd given myself enough room, I could go all the way down to -8 here, and I would have a couple more points. So I'm just going to have to, oops, that should be over there. I'm just going to have to fudge it a little bit, and hopefully you can draw yours a little less wiggly than mine. Okay, now let's take a look at number 4. All right, so we have f of x equals 1/2 x squared plus x plus 1, and then the y-intercept is going to be 0, 1. Now let's find the x-intercepts. And you know how in the last problem I decided to simplify by multiplying or by dividing everything by -2 before I used the quadratic formula? Here I'm going to simplify by multiplying the whole equation by 2 before I use the quadratic formula because I don't want to have a fraction in there. So now we have x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. So we get -1 plus or minus the square root of -4 over 2. And the square root of -4 is going to be 2i, so -1 plus or minus 2i over 2, and that's going to be -1 plus or minus I. So those are the values of x. Now those are not real. And if they're not real, you can't graph them on your standard coordinate system which has real x's and real y's. We're not talking about graphing complex numbers, we're talking about graphing a function with real x's and real y's. So there are no x-intercepts. There were roots, but the roots were not real. The discriminant is what? The discriminant is negative. That's what led us to having the non-real numbers. The roots are non-real. You could say complex, but complex is not specific enough. You can say imaginary if you want to. The graph has 0 x-intercepts. So there is still a vertex. We still have our opposite of b over 2a at -1. And so if we put that into the function, what do we get? Looks like we just get 1/2. So the vertex is -1, 1/2. Okay, so we have a couple of points. If you also think about the vertical stretch or shrink factor, because of the 1/2, that's a vertical shrink. Half is tall. So let's plot the vertex, -1, 1/2. And the y-intercept at 0, 1. Let's draw in that axis of symmetry. I kind of missed, oops. And then let's reflect that point that's on the y-axis across. And then remember the over 1 up 1 thing and over 2 up 4. Instead of over 2 up 4, it would be half of that. So over 2 up 2 from the vertex is going to take us to right about there. So that gives us a couple more points. So this parabola is a little more wide. Okay, so we've had practice with a lot of things in these last 3 problems. We practiced the graphing as well as the quadratic formula, reviewed a lot of things that we learned in the beginning of the chapter about functions, and we also learned that the discriminant being positive, 0, or negative is going to tell you what kind of roots you have and whether or not you have x-intercepts. Okay, I'm going to end the video and start part 2 because we have a little bit more to do, but this is getting a little long. So this will be the beginning of part 2.